Greetings everybody, my name is Zoe. Welcome back to Let's Code. This is just a very loose, freeform kind of me sitting down and programming a thing. I've done a couple of episodes before this one. I was working on a platformer and I got really stuck trying to program moving platforms and pushable blocks, which required me learning physics. And holy shit, physics are just I can't, oh my god. So I was working on that for basically a month, and I decided I am sick and tired of doing that. So I am going to take a break and work on this. If this game gets going like really strongly, I may finish it. We'll see. Maybe I'll start working on the platformer at the same time as this. I'm not sure, but we're gonna see. So this game that I'm making right here is a Harvest Moon style farming game. Except it's only about farming. So the other Harvest Moon games, they have like marriage mechanics, like fishing and other sort of miscellaneous mechanics. Stardew Valley has all sorts of stuff. It's got like a mine, it's got like scavenging, it's got crafting, it's got all that. But the thing is that the way I like my farming games is extremely only about the farming. When I played Stardew Valley, I did not interact with any of the other mechanics because I don't find them super entertaining. This mainly stems from my favorite Harvest Moon game being the one for the Game Boy Color, which due to it being on the Game Boy Color means a lot of its mechanics were stripped out, and I found it super minimal, extremely focused on pretty much exclusively farming to be deeply satisfying. And there was also a mechanic in it where in Stardew Valley you put all of your crops into the shipping box, and then every night it all gets sold and then you get money. But the way this game worked is that the shipping guy came at 5 p.m. in game, which is about 3/4 of the way through the day, so not at the end, which means you had less time to get your crops put into that shipping container. And so that means whenever your crops were harvested, it was a rush to get all of your crops in as quickly as possible. And if you got all of your crops in, that means you got a full harvest, which means you could maximize the amount of crops you could purchase the next day, and then you could start growing those, and then yada yada yada. So stemming off of that central idea of rushing to fit all of your crops into this thing in a short amount of time, I want my Harvest Moon game, my farming game, to be about managing your time and managing your space. And that's kind of what I'm going to focus on. I've got some ideas. I've got some design ideas for how I'm going to pull that off. And yeah, but I will get into those more as we go on. So I've actually recorded another episode before this one, but I was editing it and it just wasn't very entertaining. I'm going to, I still need practice working on these episodes. I want to have it be less me just sitting down and typing and more me actually explaining what is going on, because that is more easy to comprehend instead of just looking at the code that's sitting in front of me, because it's split between a bunch of different files. So basically that's me saying that I've already gotten a little bit of progress made on this, and I'm just going to jump in and run it and you will see what's going on. So far, we have a pink rectangle sitting here in the corner, and I've implemented a camera. Pretty cool. And that's pretty much it. These tiles right here, these are just tiles. Inside of my game file, I have this thing called a tile, and it's going to have many more variables inside of it, but currently all it stores is a color. And inside of our game init, I just malloc space for a 16 by 16 grid of those, and then I just set the color. And yeah, so that is what this is. This is just a grid of tiles. And yeah, so something that I want to do right now is I want to try and get some textures in. I have created a couple of sprites. I threw together a very basic little like running sprite just to use temporarily. And I also have this is just a basic grass tile that I'm going to use. So I want to add textures to my tiles, and I want to add animations. So textures are going to be very straightforward. You load your textures via SDL, and I want to have a like texture pointer to something else, because having to load a texture into every single tile is going to be ridiculous. But if we store one texture sheet and have them all point to that, it's going to be totally fine. And then I'm going to have a texture rect which is going to define a portion of that texture to actually draw. And I'll get into animations later. So let's try and get started just importing that debug grass sprite that I've made. Alright, so what I have done is I have gone into our game struct here. The struct holds everything we need about our game specifically, like our world, the player itself, our camera. But I also held a pointer to some STL surfaces called assets. And the gist is that every time we load an asset, it will be loaded into this array. That's what this is. It's a pointer to an array. And I also added a function called GameLoadSprite. And if we go over to the implementation, what I do is I iterate the asset count by 1, and then I reallocate the space. So we have space to actually put the new asset. And then I load the image, and if it loaded correctly, I set the most recent position in the array that's been added to image, and then I also return a pointer to that image right here. So now we can go up here, we can go into game.h again, and then what I'm going to do is I'm going to have STL surface pointer texture, and I'm also going to have a rect. This is my own rect implementation. It's just floats of an x, y, width, and height. Rect, and we're going to go texture rect. And now what we're going to go is we're going to go into game.c, and we're going to go into, where's our init function? Yeah, here we are. Game.init, and right here I am just simply setting these. What I want to do instead is I want to delete this debug color. Actually, you know what? I think I'll leave the if I want to delete the debug color, I'm going to have to change the functionality of my rendering. So currently this is kind of wonky. Because if I don't have a debug color, this is going to not work properly. Yeah, actually, real quick, something I need to do is I need to modularize my tile struct a little bit more. So here's what I'm going to do. I'm gonna have a bool has debug color, and inside of game.c, I'm going to go into this function right here, and I'm going to make game world y plus x dot has debug color is going to equal false. And now over here what we're going to do is we're going to go if game dot world y plus x dot has debug color, and we are going to do the following. So now this will only draw our debug color if it actually has a debug thing. I'm basically implementing like a very like extraordinarily like basic almost entity component system style thing with this has debug color thing right here. I'm gonna add another thing that's gonna say has texture t.has debug color like that. Cool. Oh, and that's a pointer, so we have to do the arrow operator, and then has texture is going to equal true. Look at that. And now we are going to go t dot texture is going to equal game load sprite, and then we're going to pass in a pointer to our game, which is being passed in up here. We're going to pass in a pointer to our game, and then we are going to pass in assets slash debug tiles.png. Cool. And then, and then we're going to go t.texture rect is going to equal game, it's going to equal a rect, and it's going to start at 0, and it's going to end at 1616. So now we have to go into here, into main.c, this is where we are rendering. And then we're going to go if game.world y plus x dot has texture. We're going to go SDL render copy SDL texture. I forget there's a difference between SDL texture and surface. Alright, so a texture is just a block of pixels. Sorry, a surface is just a block of pixels, but a texture is going to be something different. So, alright, I misunderstood how SDL handles things, so I'm going to have to change things around a bit. Alright, we should be good to go now. I have changed up the function to return an actual texture. I also had to change this up because inside of SDL, the SDL texture can exclusively be a pointer. It cannot be just a straight up texture. I believe because it's pointing to data on the GPU. So SDL texture is always going to be a pointer. So I had to change this to a pointer to pointers. Pretty straightforward. Now, inside of main, we're going to render copy. Alright, so I was correct. The source rectangle is going to be the sort of rectangle that we're drawing from the texture itself, and then the destination is where on the screen it is going, which is going to be our X and Y from us iterating the level itself. That minus the position of the camera. Something I still have to do is figure out how to figure out clipping. In fact, I should add that to my to-do list real quick. Level clipping, so we aren't rendering textures that aren't on screen. That would be silly. So I have my source and I have my destination. Let's see if I did everything correctly. I did not. All right, we have segfaulted. Wait, no, these are just undefined reference. I forgot to include SDL image. Oh, I've included the library properly in my make file, but now we got some memory issues. I am messing something up. Alright, I had to mess around with pointers. Moral of the story is, always make sure you are setting your data. My assets pointer was pointing to just junk, and I, inside of game init, inside of main, I set game to be an empty structure, and then we populated in here. Asset count is 0, and then inside of game load sprite, we pretty much do exactly the same thing we were doing before. And so what happens here is we return a pointer to a texture, and in SDL they're all texture pointers, so it's a pointer to a texture pointer. And then up here inside of game init, we grab that texture. We grab whatever's at position 0. Position 0 is what the tile's texture is, which I loaded up here. Boink. And I set has texture to true, and I set the texture rect. And if we load up this, look at that. Also note my player is actually slightly off center, but these are our little grass textures. Look at that. Hell yeah. That is pretty fucking dope. Now, I don't have a lot of time left, but I want to start working on animations. So, for animations, I'm going to make a whole new struct for it. And I'm going to plonk it right here. Type struct animation. And here is kind of the gist of an animation. So I am going to have a rect pointer called frames, and this can have as many frames in it as we want, and those define portions of the texture that we are going to draw. And you know what? I might have animation itself point towards a texture. Yeah. And yeah, here. Let's add that to the to-do list. Animations include its own pointer to a texture. And since it's just pointers, we can have as many as we want. Pointers are cheap. So what's going to happen is we are going to populate this with frames. Every single frame we are going to iterate this. So it's going to be 0, 1, 2, 3, etc. Until we hit frame count, whereupon it's going to loop. And that should be good to go. I said I was going to add the texture later, but I think I might just do that right now. pointer to a pointer, texture, animation.texture. Yeah, that is gonna make plenty of sense. Cool. You know what? Let's make a function for new animation, and I'm going to fill out this function real quick. And by fill out that function, I hope you mean completely scrap everything and start over from scratch. So I completely ditched the original plan I had for my animation system. Instead of having a pointer to a bunch of rectangles, which define the different frames, I did something completely different. The reason why the array of rectangles thing doesn't really work is because in order to add a new animation, I would have to allocate out those recs, set the recs, and then mem copy into the other pointer, which was incredibly annoying. So what I did is I did something different. So kind of the gist with this animation system, this is very similar to what I've done in my other game, where you basically define an animation, and an animation has inside of it different sequences. So the sequence is the literal like series of frames, and the animation stores all the needed information. And then you could define the frame width, frame height, and then these would define here the starting position and then the length of the animation. And then you pretty much just set the current sequence and then update it, and it pretty much just works. So, let's see. Sorry, I briefly forgot the keyboard shortcut to switch windows. So over here, this is very basic. New animation is very basic. New sequence is very basic. Set sequence, now what this does, a little neat thing, is that inside of your update functions, you typically will run this multiple times. So if you are setting the sequence to something, if you set the sequence to a sequence that's already running, it won't do anything. And then update animation is very simple. It just takes up the frame counter, and then if the frame counter exceeds the frame length, it'll take up the frame that's currently on. And then I also made a little convenience function here, which passes out a rectangle given an animation. So if we hop over to game.c, and if we run down to game.player, you can see how things work. So this is new player, and this defines a new player, obviously. So you can see here, I add the animation right here. This is just animation speed, so I don't have to type out 8 over and over. But you see here, new sequence. You see I give it the animation, and then here, this is idling, so it doesn't actually move, but it's a start X, start Y of 0 up in the corner, and then an animation length of 0 and a frame time of 0, and it does not loop. But then here, the animation length is 4 frames. Each frame is 8 ticks long, and it does loop. And these are all added. So the way that you actually set the sequence is you use a number. So this is actually an enum, but it accepts an index. So you could do 1, 2, 3, 4. And these new sequences, they do actually return the index that it just added to. So like right here, this would return 0 because it just added to 0. This one would return 1, 2, etc. But just as a little bit of syntax sugar, inside of the player, let me go over to game.h real quick. I defined an enum right here, and an enum in C is just like a fancy way of defining numbers. Here, idle up, idle down, move down is literally 0, 1, 2, 3, 4, 5, 6, 7, and so on. So it's just a little convenience thing. So that instead of setting this to like instead of just setting this to 5, I can set it to move left, and it just reads out easier. Also inside of player, I hold on to an idle animation, inside of update player here, when it sets it, it also sets the idle. So when you're not touching anything, it already knows. That didn't make any sense. The idle animation stores the previous held direction, so then things look nice. So let me just show off what I've done. They should just run. Yeah, so here we are. And you see my little character here. I should probably make this bigger for the camera. But you'll notice we have our little animations going. And in the background, you actually see some debug variables that I was using when I was working this out. But yeah, that is a pretty slick little animation system. The only issue currently, and it's with my implementation inside of the game update, if I go diagonally, I kind of like slide along. But yeah, so that is an incredible amount of progress for the first episode. We did the camera, we did a little bit of textures, and we also did animation. This is a really, really, really good start to what we got going on. In the next devlog, I'm going to be working on platform independence type things because I, with SDL supporting multiple PC platforms, Mac OS, Linux, Windows, that's very simple. But I actually want to eventually put this on mobile devices. So I want to make sure that my multi-platformness is actually pretty good. So that is where I am going to leave it. Animations are done. Hell fucking yeah. And yeah, I'm going to end that one here. So yeah, thank you so much for watching. And I will see you in the next one. Toodles.